Hello everyone. In this video I am going to demonstrate a digital vernier caliper using an LVDT. As you can see, this is a digital vernier caliper. This is my model. As you can see here, this is the scale, and presently the LVDT is partly out, the core is partly out, and you can see here I am measuring 50 from 0. If you see, this is the 0 to 50. My LVDT should be measuring 50 millimeter. As you can see, it should be measuring 50 millimeter. So let us see the reading. So my LVDT here, you can see, is measuring how much? 49 millimeter. And I am reading 3.4 volts DC. You can see. So this is how it looks like. It is matching. Now I am going to adjust the LVDT core. I can adjust the LVDT core. So let us make it 55. So it is somewhere 55. So if we see here, I am measuring 53 millimeter. You can see I am measuring 53 millimeter. How much I was? I am somewhere near 53 to 55. It is measuring 53 millimeter. And here you can see I am reading 3.6 volts DC on the multimeter. Now I am going to make it 60, somewhere 60. I am going to measure somewhere 60. So you can see here my reading is 58. The voltage on the multimeter is 3.9 volts DC. 3.9 volts DC. So this is how my LVDT setup works. Now as you can see here, this is my oscillator. As you can see here, this is my oscillator. So this is 555 IC based oscillator, and here is the 555 IC. That is the heart of the circuit. You can see this is the heart of the circuit. This is the oscillator. It is oscillating at a frequency of 55 kilohertz, and there is a current limiting resistor feeding to the MOSFET, and from the source of the MOSFET my LVDT is connected. As you can see here, my LVDT is connected. Now the LVDT output is rectified with a Schottky rectifier and filtered with a 1 microfarad capacitor, and there is a 100 kilo ohm load. And here you can see it is connected to the channel 0 of the Arduino Uno, and here is the LCD. We can see the reading, and here is the multimeter reading in parallel to compare. So this is the basic setup. So this is how a digital vernier caliper can be made using LVDT. This setup can be implemented using LVDT. Like this, a digital vernier caliper can be made using LVDT. So let us see the circuit in short. So as you can see here, this is the 555 timer IC oscillator. It is oscillating at 55 kilohertz, and the output is fed to a MOSFET IRF 840 12 volts DC powered circuit. It is exciting the primary of the LVDT, and it is connected like this to the ground. Secondary of the LVDT is connected to Schottky rectifier with a capacitor and 100 kilo ohm load connected to Arduino Uno, and it is displayed here using serial display, SCL and SDA serial display. So as we move up and down, move the core up and down, the voltage on the secondary will change. This is the theory of the LVDT, linear variable differential transformer. So this is how, if we can scale it, we can scale it to some scale. The reading, if we can scale it, we can get the millimeter difference. The length it has traveled out or in. So this is how it can be implemented as a digital vernier caliper. So let us see the circuit again. This is the LVDT, and this is the display. You can see it is 49 millimeter, and here is the multimeter reading. So that's all for now. Thanks a lot. Thanks for watching.